So it has come to my attention that a lot of people have not actually learned the difference between what weak induction and strong induction is through no fault of your own. Apparently, it just was not covered in a lot of the sessions of Math 122 that people have taken. So I've taken it upon myself to explain the difference because I think it is important to know, and it will certainly help you in your assignment too. So let's take a look at the difference between weak induction versus strong induction here. We have that. Okay, so we have for weak induction that the induction hypothesis holds at one step k. And for strong induction, the induction hypothesis holds from all steps up to some number k, which is less than n. Okay, so this is stuff that we have looked at already in the induction that we've done. In weak induction, we often have assumed that the claim holds for all or for some L between our base case and that is less than n. For strong induction, we are now allowed to assume that the claim holds for all, let's call it I, that are less than 2 or equal to L, but still strictly less than n. Okay. Now you might be looking at this and rightly thinking, this is still very abstract. What does this actually mean in terms of practicing induction? Well, let's take a look at some analogies. Here we have my favorite cat analogy, where we saw at the beginning of the term, I have multiple cats, okay? All the cats in the world, they are lined up in one line. Okay, let's say that this is the line of cats. This is your starting cat. And then these are just some other cats that trail off into the distance, okay? Furthermore, we know the starting cat is red, but we don't know the color of any of these other cats, okay? So we also have this condition where if two cats are sitting beside each other, then they are going to be the same color, okay? So if we have color of, let's say, some number I, cat number I, then it's going to be the same color as color I plus 1, the cat that's sitting beside it. Okay, so if we know the first cat in the line is red, we can then conclude, as again we went over in the first lecture, that all the cats in the line must be red, right? Because we have that this cat is sitting beside that cat, so it also has to be red. And then this one is sitting beside that one, so it also has to be red, and et cetera, it just travels up the line. So we know just by the first cat being red that every single cat has to be red. Let's look at a variant of the same problem where we now have this constriction or restriction. So we now have that only if two cats in a row are red, then the third cat has to be the same color. So we redraw our line of cats here. Again, this is the first cat. This is going to be the end of our line here. And we have now this restriction where if we have two cats in a row that are the same color, then the cat to the right of those two cats is going to be the same color, okay? And we can write this in terms of color. So if color at I equals color at I plus 1, then color at I plus 2, I plus 1, is going to be the same as color at I, which is the same as color at I plus 1. Okay, so we have two cats in a row. The third cat is also the same color. Now, if I have, in my example, we go back and we take the exact same assumption or base case that we had before. Okay, so now in the previous example, my base case was we know the first cat is red. Okay, if we wrote this out in terms of actual base case, we know that color at 0, so the 0th cat is red. Okay, is this now sufficient? If we just know that the first cat is red, is it now sufficient to still prove that all the cats in the line are red? No, you can see now this is no longer enough, right? We need to show that the first two cats in the line are red. And after the first two cats in the line are red, then we can say, okay, well, now these two are red, so this one must also be red. And then now these two are red, so this one must also be red, okay, et cetera, et cetera. But you can see here that there's definitely a difference, okay? So this is the analogy of using strong induction. The previous was weak induction. We assumed that at some point in the line, one cat was red. Okay, and that was enough for that problem. We could then go on to assume, therefore, the entire line of cats is red. Using strong induction, it is no longer sufficient to just assume that one cat is red, because the definition of our next cat depends on not only the cat before it, but the cat before that one. So it depends on 2, maybe 3, 4, etc., multiple previous cases. And because it depends on multiple previous cases, it's no longer sufficient to just say, well, one of these cases is red, right? We now need to prove that all of them are red. If we go ahead and write this out, like my analogy that I like to use is for the inductive hypothesis in weak induction, then we assume that there is some number L, right, at which point the inductive hypothesis or the claim holds. Okay, if we have our cats, then we just know that some cat at L is red, let's say. Okay. For inductive hypothesis for strong induction, we now have a whole set of numbers. Okay, everything between our base case, which again, let's assume is 0, and L inclusive, all of these are red. So color at 0 is red. If I abbreviate this to C, C of 1 is red. C of 2 is red. C of L minus 1 is red. All the way up to C of L is red. Okay, so we now know that everything within this span, all of those cats are red. Okay, that's our hypothesis. Compared to in weak induction, we just know that this cat at this one point is red. Okay, and then we have to prove at the next point that cat number L plus 1 is also going to be red. Okay, now in strong induction, we can prove cat L plus 1 is going to be red, but we know that all of these cats from 0 to L inclusive are red. So that is the difference between strong induction and weak induction. Weak induction, we assume, again, only affects the inductive hypothesis step. Weak induction, we assume that our induction hypothesis holds at only one point. Strong induction, it holds at a whole set of points. Okay. Hope that helps.